Welcome. In this video I'm going to show you how you can perform a Neyman Goodness-of-Fit test using Python and my stikpetP library. I'm using Jupyter Lab and Python version 3.11.5. This video will focus on on how to obtain the output, not if you should be using this test, because perhaps you want to be using a Pearson chi-square test of goodness of fit instead, or some other test. I'll also be using it there for Neyman test as in an alternative for a Pearson chi-square test of goodness of fit. So there are some other Neyman tests around. This is just about a basic goodness of fit test as with the Pearson one. I have a separate video if you don't want to use my library, so you can watch that. And let's dive in. So to show you how you can perform this test, I'll of course need some example data, so I'm going to be loading in pandas, so I can use the read CSV file function. I'm going to be loading in a file called GSS 2012A. It's slightly different than the original General Social Survey. I adjust a few things over the years just for example purposes. I don't need all the data, I only need one field, so I'm going to be using the marital field as the example. And once I've loaded that, I can use value counts from pandas to give you a quick indication of what the frequencies were. So for example, 314 people selected divorced. Now my library, you can install that by using pip install, but then use the entire URL shown here. Let me see if so it's only available on my GitHub account. Once you've installed it, you can actually import it just as any other library. The input will be the data, of course, and if you like, you can also specify which expected counts there are. Otherwise, it will simply use the sample size divided by the number of categories, which is equal then to assuming that each category would have the same count in the population. If you like, you can use a continuity correction. Options are Yates, Pearson, and Williams. And if you want, there is an option for modified, but that's not available for the Neyman one. So I forgot to actually change a few things in here. I will change it to Neyman because that's the one we're actually after here. So this should have been TS Neyman. There is no modified, so that should actually be removed. And just in any doubt, you can always simply get any information about any of the functions by using a question mark. So before I show you the results, you could do something like this, and then it nicely shows you a little bit more information about the function as a whole. Alright, there's also a Yates 2 option for this one, as you can see. I'll adjust this Jupyter notebook later. Let's run the test. As you can see, it spits out the sample size, the number of categories, the chi-square statistic, the degrees of freedom, the p-value, which is also sometimes referred to as the significance. And if that's below 0.05, or that's the usual threshold, we would reject the assumption about the population. And in this case, it would mean that they're not equally distributed. The minimum expected count, some will have some thresholds for this. Most often it should be at least 1. Well, it's 388.2, exactly that 1941 divided by 5. It also shows the percentage of cells that have an expected count below 5. Some will say that should be at most 25%. Some will actually say it should be 0. And of course the test used. If you do have some specific expected counts, for example these, you can simply create a small data frame with those counts, like I've done here, and then you can feed that to the function and you'll get the result. A quick showcase of all the options. So for example, we have Yates. We should also have Yates 2, as we saw earlier. So let's see if they're all working, and they all seem to be working. Alright, and that's it. I hope this video was helpful, and thank you for watching.